This video is on proportional relationships and unit rate and how unit rate and slope are related. So let's go back to what we did in the last section, and that is y equals mx plus b. That's our linear equation, and that's very important. We're going to continue to use that for quite a while now. And if we remember, the b is our y-intercept, so that means where this line crosses the y-axis, and our m is our slope. That is the steepness and direction of the line. So the slope can also be called rate of change. It's a new word, a new term potentially, but it really means the same thing as slope. If we're referring to word problems or any kind of real life situations, we also often will hear it referred to as rate of change. However, if it's as we're talking about just the equation itself, then we will typically hear it called slope. But they really are the exact same thing. Just as an example, I have a real life situation here for us. This is saying the time that you spend driving, and the units are hours. And then we have the miles from home, or we could think of that as the distance in miles. This is just a table of data where, of course, this is the x and this is the y. So this is really giving us ordered pairs. 2, 60, 4, 120, and so on. So I'm going to take those and I'm going to graph them here on my graph. I already went ahead and labeled it for us. In my x coordinate here, I labeled that time and I counted by ones. But in my distance, on the y-axis, I actually counted by 20s because these numbers do go up pretty quickly. So let's go ahead and plot these points and we'll see what happens. There we have it. And I can see that I have a straight line. So let's go ahead and put that straight line in there. If you notice, there's something very special about this linear equation. Right here, it goes through the origin. This is a linear equation like we've been used to working with, like you did in the last section, with one difference. It's a very special linear equation. It's called a proportional relationship because it goes through the origin. So the proportional relationship is a linear equation which goes through the origin. So therefore, in all of these proportional relationships, b equals 0. So you won't see it written because it equals 0. Then we're going to talk specifically about the unit rate. That is a slope where the denominator is 1. We're now going to move on to the papers which you printed out that were on this page for you to see. If you did not print these papers out, please hit pause and go ahead and do that, where you're going to use these as notes, and then you'll have those so that you can complete your assignments with these pages. They'll help you out. Okay, so let's see, we want to go to, yes, this first page right here, lesson 4, it says comparing proportional relationships. So we're going to start by talking about unit rate and slope of the line, which we just talked about a little bit. Again, unit rate and slope of a line are really the same thing, just that unit rate will have 1 in the denominator. So it's just a little bit different. If I think of the slope of a line, I could have 4/5, for example. That would be a slope. But a unit rate would have to be a specific. It would have to be 4/1. Okay, so they're the same thing. They mean the same thing. It's just the form in which we show it. Unit rate always has a 1 in the denominator. So that's talking about this, is telling you about a unit rate, and it's telling you about the slope of the line. You can see how they're finding the slope of the line here. We know 2 ways to do that. One is with our slope formula. So it's m equals y1 minus y2 over x1 minus x2, and we can do our math and get our slope. We can also use our rise-run triangle, and that will also get us the same slope. So let's look down to this example. It asks us just to find the slope. and to determine the unit rate of this proportional relationship. And just to review, proportional relationship means that the linear equation is a specific linear equation which goes through the origin, which this one does. So what I'm going to do is I'm going to label these points here as x1, y1, x2, and y2. Make sure you're copying this down as we go along. That way you'll have your notes for you to complete your assignments. They already have this set up. They want us to find the slope here. So we have y1, which is 5, minus y2, which is 0, x1, which is 1, and x2, which is 0. When we do our math, we're going to get 5 over 1. And this is a unit rate already. We don't have to do any simplification because 1 is in the denominator, so that makes it a unit rate. Why don't you flip your paper over? We can look at the next side. This is another example for us. This is actually talking about the cost per pound. So we have the cost down here, and then we have the pound here. So that's pounds. So let's see if we can find this unit rate. And we want to choose 2 points. So I'm going to choose this one because the origin is always the easiest one to choose. And I want to choose one which goes through perfectly, which meets where these lines on my graph are crossing. Then I'll have whole numbers. So like that would be a good choice. That would be a good choice here or here. Doesn't matter which I choose. We'll just go down here and make our rise 1 triangle here. And I'm going to count. Change in the y direction is 2. And then the change in the x direction is 1. So that, without doing the math, because instead of the slope formula, I went ahead and just did my rise 1 triangle to show both ways to get the slope. I'm going to put that in as 2 over 1, and that is a unit rate. So my unit rate is 2 over 1, and the cost is $2 per 1 pound. So that's how that one works. What I'd like you to do is I'd like you to hit pause on the video and go ahead and complete this practice 1 through 4 and find each of the unit rates. Here are the answers you should have gotten. So for number 1, I did my rise 1 triangle. It's 1 over 1. So here I have my unit rate. Number 2 is 4 over 1. Number 3 is 3 over 1. And for number 4, just be careful when you count. I made my rise 1 triangle. These are going up by 2s. So when you count this way, you have to count by 2s to get 8. And in this direction, it would just be 2. And I have to simplify that because remember, this one here is a slope, but it's not a unit rate. This one is the unit rate because it's over 1. So here's my unit rate, 4 over 1. You can move to the next page now. It says Power Up, Graphing a Proportional Relationship. This is talking about proportional relationship specifically, and remember that they always go through the origin. So you can see here on this graph right here that it's going through the origin. So not only is this a linear equation, but it is a proportional relationship. So here we have that. All right, so we have an example down here. Let's see if we can do this. This is asking us, is this a proportional relationship? So we want to see if we can identify it by graphing a table of data. So we're going to take this table of data and then we're going to graph it and see what we get. So if you'd like to do that, hit pause and do that as well, you can. 1, 4 is there, 2, 8 is there, 3, 12 is here, 4, 16, and 5, 20. I'm going to take my nice straight line, and I can see that I can hit the origin and all of those points. So this definitely goes through the origin. So this is definitely a proportional relationship.